now we will continue the one important concept. The concept is basically Descartes' rule of sign, and this Descartes' rule of sign is one of the celebrated theorem in the theory of equation. By using this Descartes' rule of sign, we can conclude the maximum number of positive roots or maximum number of negative roots. So now first we will know what is exactly the statement of Descartes' rule of sign without proof, and then we will continue many problems, important problems related to Descartes' rule of sign. Especially we will solve the schema of a book exercise, and this is basically exercise 5b that we will solve. Okay, now we'll continue. So first we'll know about the statements of Descartes' rule of sign, and we state here without proof a celebrated theorem of Descartes known as Descartes' rule of sign. So now the first question is state Descartes' rule of sign. Descartes' rule of sign. Rule of sign. So what is the statement? Now we'll write the statement. What exactly the statement of Descartes' rule of sign that we need to know first, and then we will solve some problem. Here the statement is the number of positive roots, the number of positive roots of an equation f(x) equals to 0. Mainly we are taking the algebraic equation or polynomial equation with real coefficient. With real coefficients. So that means here f(x) belongs to Rx. The coefficient is coming from real number. So the number of positive sign, the number of positive roots of an equation f(x) equals to 0 does not exceed the number of variation of sign, the number of variation of sign in the sequence of the coefficient, in the sequence of the coefficients of f(x), and if less, it is less by an even number. It is less by an even number. So what exactly is said in this statement? I'm writing a note. Say you have given a polynomial equation f(x) equals to 0 where f(x) belongs to Rx. That means the coefficient comes from the real number. Now you just consider, let R be the number of positive roots. Number of positive roots obviously positive real roots, the roots are real, positive roots of fx equals to 0, of fx equals to 0, and let v be the number of variation of sign in the sequence of coefficient of fx. The number of variation of sign in the coefficient of fx. Coefficients of fx. Then by the given theorem or by the Descartes rule of sign, then we conclude that the number of positive roots are less than equals to v, and even and what is written, it does not exceed the number of variation of sign in the sequence of coefficient of fx. So that means r less than equals to v, and if less, it is less by an even number. And furthermore, we say, what is the relation between r and v? V equals to r plus 2h. What is h? Where h is non-negative integer. So h belongs to z plus union 0. So this is the statement. That means if it is less, then it is less by an even number. So these two information are very, very important. Okay, so that exactly says the Descartes rule of sign. The same thing we can apply for the negative roots. If you think about the negative roots of an equation fx equals to 0, then the number of negative roots fx equals to 0, negative real roots here, with real coefficient, that is also does not exceed the number of variation of sign. So we have trying to write the corollary. So this result is also holds for the number of negative roots. Or we can say the deduction. So here the deduction is the number of negative roots, of the equation, algebraic equation fx equals to 0, where fx belongs to rx. This also does not exceed the number of variation of sign, the number of variation of sign in the sequence of coefficient, of f of not x, f of minus x, because we are talking about the negative root. So x is replaced by minus x, and if less, it is also less by an even number. It is less by an even number. So for number of negative real roots, we will think about the coefficient of the variation of sign in the coefficient of f of minus x, and we will conclude the result. So now we will come to one problem, and from problem you will understood what is the maximum number of negative and maximum number of positive real root exist of an algebraic equation. So from that we can find out we can examine the nature of the roots of any algebraic equation fx equals to 0. Now we'll come to the steps and we'll apply Descartes' rule of sign to examine the nature of the roots of the equation. See, here I will take one important example. So our example is question. This question is very, very important. What is our question? Our question is apply Descartes' rule of sign apply Descartes' rule of sign to examine the nature of the roots of the equation x to the power 4 plus 2x square plus 3x minus 1 equals to 0. So we will solve this problem by using some steps that comes under the working procedure. How to solve? We'll do parallelly. So the working procedure for finding the nature of the roots of an equation fx equals to 0. What is fx? Fx belongs to Rx. That means all the coefficients of the polynomial equation or algebraic equation must be a real number. So first what we will do? Step 1, we will write fx and f of minus x. Just you will replace xy minus x. So now I am writing here the solution. So here, what is fx? Fx equals to x to the power 4 plus 2x square plus 3x minus 1. Now, then, so that let fx. Then what is f of minus x? F of minus x is minus x whole to the power 4 plus 2 into minus x whole square plus 3 into minus x minus 1. That will be x to the power 4 plus 2x square minus 3x minus 1. Now we'll think about the variation of sign in the sequence of coefficient of fx. So that will be our step 2. So we will think about the variation of sign in the sequence of coefficient of fx, and we apply Descartes' rule of sign. Okay. So now we'll come to the step 2. So what is the number of variation of sign in the sequence of coefficient of fx? So the number of variation of sign, the number of variation of sign in the sequence of the coefficient of fx, in the sequence of coefficient of fx are as follows. Just first the coefficient is positive 1. Second, the coefficient is positive again because it is 2. Then the coefficient is 3, so you can write is positive, and then the coefficient sign is negative. So how many sign variation of sign? There are only one variation of sign. Okay. So you write here the variation of sign in the sequence of coefficient of fx are as follows. So therefore, the number of variation of sign in the sequence of coefficient of fx. So plus to plus, no variation. Here is also no variation. There is only one variation, is 1. So that means there is only one variation of sign. Therefore, there is only one variation of sign in the coefficient of fx. So therefore, we conclude that the number of positive real roots of fx equals to 0, it basically does not exceed 1. That means it is exactly 1. Again, we will see the number of variation of sign. Again, we will check next step 3. Now we will check variation of sign in the sequence of coefficient of f of minus x, and we apply the Descartes rule of sign. This will be our step 3. So what we will write now? We will write the variation of sign. The variation of sign in the sequence of coefficient, of coefficients of f of minus x are as follows. Next we will think f of minus x is plus, plus, minus, minus. This is plus, plus, minus, and minus. That means there is no variation of sign. This is the only variation of sign. There is also no variation of sign. So we have seen also here there is only one variation of sign. Therefore, the number of variation of sign in the sequence of coefficient of f of minus x, this is basically 1. That means there is only one variation of sign. So what we conclude, the number of negative real of fx equals to 0 does not exceed 1. That means it will be exactly 1. So therefore, the number of negative real root of fx equals to 0 is exactly 1. So now we come to the next important check. This will be our step 4. We will check f of 0. That we need to check. If f of 0 is non-zero, that means 0 is not a root. And f of 0 equals to 0. So 0 is also a root. So now we'll check f of 0. So the next step. So now, what is f of 0? F of 0, our fx is, that will be minus 1, and this is non-zero. And that implies fx equals to 0 has no 0 as a root. 0 as a root. You can say the f is equal to 0 has no zero root. No root as 0. That means 0 is not a root of the equation. That is, 0 is not a root of f(x) equals to 0. So here we have seen the number of positive real root is 1. The number of negative real root is 1. There is no zero root. So that means the number of real roots of the equation is 2. So now next step, that means step 5, will conclude number of real roots. That will be number of positive roots, real root, plus number of negative real roots plus 0 as a root. That number. So thus we conclude the number of real root, the number of real root of f(x) equals to 0 is 1. The number of positive root is 1. The number of negative root is 1. And 0 is not a root. So that means total number of real root is 2. So since the equation is of degree 4, so number of complex root will be 4 minus 2. So what we will write? Since degree of f(x), this is equals to 4. So by fundamental theorem, so it has exactly 4 roots. That may be real or complex. So consequently, it has a 2 real roots. So 4 root, 2 are real root, 2 roots are real. So remaining 2 will be complex. So consequently, we can conclude the number of complex root, the number of complex root is 4 minus 2. That means 2. So here we have solved the problem and we have done here the nature of the roots of the equation. So what exactly mean? I need to discuss exactly what exactly mean by the nature of the roots. Nature of the roots that we have done in this problem. Nature of the roots of f(x) equals to 0. That means you need to think about based on the degree. So number of real roots and number of complex roots. Complex roots. Complex roots means purely complex. So that sum will gives you the number of roots and that will be degree of f(x). Next, under the number of real roots, you need to think about 3 cases. Number of positive real roots, number of negative real roots, and 0 number of 0 root. And that sum will gives you number of real roots. So nature of the roots means how many number of real root exist, and how many complex number of complex root exist, that we need to determine. So this comes under the nature of the roots. Now we'll go to the next important problem. The problem is next problem 2. the number of this will give you the MCQ type. The number of real roots of the equation x to the power 4 plus 2x square plus 3x minus 1 equals to 0 is option A 0, option B 1, option C 2, and option D all roots are real. That means 4. So we have done this problem with the help of Descartes rule of sign. But what you will do in the examination? You will think about fx equals to x to the power 4 plus 2x square plus 3x minus sign. You just write the variation of the coefficient of sign. So plus 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 minus. You will write a for minus x. That means x to the power 4. This is 2x square minus 3x minus. That will be plus plus minus minus. So this is variation of sign. Next, number of variation. So number of variation is 1. Here number of variation is 1. And after that you will conclude negative root is 1. Positive root is also 1. Next we will check f of 0. So this is minus 1 non-zero. That means 0 is not a root. So that means the number of real roots, that will be 1 plus 1 plus 0. So this will be 2. So option 2 is correct. All other options are false. In that way you will solve this kind of problem quickly. So now we come to the next problem. Apply Descartes' rule of sign. Apply Descartes' rule of sign to examine the nature of the roots of the equation. The nature of the roots of the equation x to the power 6 plus x to the power 4 plus x square plus x plus 3 equals to 0. And the degree of equation is 6. It has 4 roots that may be real or complex by the fundamental theorem of classical algebra. But okay, we need to check how many positive roots, how many negative real roots, and how many complex roots are present. So now we just move according to stepwise. So our first step is you need to write fx. Let fx equals to x to the power 6 plus x to the power 4 plus x square plus x plus 3. And then you will write a for minus 6. This will be the first step. So that will be x to the power 6, x to the power 4 minus x whole square, x square. That will be minus x plus 3. Now you will check the sign, variation of sign in the sequence of the variation of sign in the sequence of coefficient of fx are. This is basically plus, 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 again plus, again plus. And also, so that means there is no variation of sign, that means no positive root. Since there is no variation of sign, so no positive roots, no positive real roots. That means here number of positive real roots is 0. Again, you will take the variation of sign, in the coefficient, of f of minus x r. So this is plus, then again plus, then minus, then plus. So here you will see the variation is here, and here is also variation. So number of variation of sign is 2. So that means you will write there are 2 variation of sign. Variation of sign, that means the plus to minus and minus to plus. 2 variation of sign. Therefore, by Descartes' rule of sign, by Descartes' rule of sign, we say that the number of negative real roots does not exceed the variation of sign, or does not exceed 2. That means it will be 2. If it is less, if it less, so then it will be less by an even number. So 2 minus 2, so either 2 or 0. And also you will check now again, you will check what is the f of 0. Your f of 0 is 3. This is non-zero, that means 0 is not a root of fx equals to 0. So what we will do, we now will conclude number of positive real roots and number of negative real roots. So therefore, the number of real root of fx equals to 0 is either 2 or 0. Because there is a case no positive root, but if the number of negative roots is 2, so that means the real root will be 2. If the number of negative root is 0, in that case the real root will be 0. So that's why I have written either 2 or 0. Now we come to the complex root. Since degree of fx equals to 6, so it has 6 roots, either real or complex. So if the number of real is 2, so on the complex root will be 6 minus 2, it will be 4. If the number of real is 0, then complex root will be 6 minus 0, it will be 6. And hence, we conclude that the number of complex root, the number of purely complex or complex root, either 6 minus 2 or 6 minus 0. That is either 6 or either 4 or 6. Now the question is like this. The number of positive real root of x to the power 6 plus x to the power 4 plus x square plus x plus 3 equals to 0 is option A 0, option B 1, option C 2, and option D 4. So there is no positive real root. That means that option is correct. All other options are false. Now we will do one important problem, which is given in exercise 5b in scheme of a book. So we'll do the exercise 5b in scheme of a book, classical algebra. And the problem is very, very important. The problem is apply Descartes' rule of sign. Descartes' rule of sine. To find the nature of the roots, to find the nature, this is question number 5, 4. Nature of the roots of the equation x to the power 7 plus x to the power 5 minus x cube equals to 0. That means you need to show how many positive roots and how many negative real roots and how many real roots and how many complex roots are there. That we need to discuss. So we'll move according to stepwise. First, we'll consider it as fx. This is x to the power 7 plus x to the power 5 minus x. Then you need to think about f of minus x. That will be minus x whole to the power 7 plus minus x whole to the power 5 minus of minus x whole cube. So it will be minus x to the power 7 minus x to the power 5 plus x cube. Now we'll think about the variation of sign in the sequence of coefficient of fx. Now we'll move to the next steps, the variation of sign in the coefficients of fx are, that will be plus, and minus. So therefore, there is only one variation of sign. Only one variation of sign. And hence we say that the number of positive real root is 1. Again, we'll think about the variation of sign. The variation of sign in the coefficient of f of minus x r. This is minus plus. Second, there is no variation, there is only one variation. So again we can conclude there is only one variation of sign, and hence the number of negative real root, this is again exactly 1. So now we need to think about f of 0. So now we will write, what is our fx? Our fx is x to the power 7 plus x to the power 5 minus x cube. That means if we take common x cube, that will be x to the power 4 plus x square minus 1. So that we can write x minus 0 whole cube x to the power 4 plus x square minus 1. And hence x equals to 0 is the root of fx of order 3. Because the 0 is a root of fx 3 times. So that means now we'll think about the number of real roots. Therefore, number of real roots of the equation x to the power 7 plus x to the power 5 minus x cube equals to 0 is, the number of positive root is 1, number of negative root is 1, and 0 is a root of 3 times. So that means it is basically 5. So since degree of fx, this is basically 7. So it has 7 roots. Out of 7, 5 roots are real. So that means the remaining root will be the complex. And consequently, we conclude that the number of complex root is 7 minus 5. So this is basically 2. Now we come to the question. The question may be like this. The number of real roots of the equation x to the power 7 minus x to the power 5 plus x to the power 5 minus x cube equals to 0 is option A 1, option B 3, option C 5, and option D 7. So we have seen 0 is the root of multiplicity 3. Number of positive real roots is 1 and number of negative real roots is 1. So number of real root will be 5. Now you have given one assignment or homework. We will solve. This is also important, x to the power 8 plus 1. In that case, how many real root exist of x to the power 8 plus 1? You can ask the question, the number of real roots of the equation x to the power 8 plus 1 equals to 0 is option 0. That means no real root. Option B, two, option C 4, and option D 8. Okay. So how we will solve this problem? If you have given the number of real roots of the equation, how will so this question is important for TIFR type of examination, the number of real roots. So here your fx is x to the power 8 plus 1. You will check the variation of sign, that will be plus plus. So here the variation, the number of variation, this is 0. So that means there is no positive real root. So the number of positive real root in that case is, that is no positive real root. Similarly, if we take f of minus x, that will be minus x whole to the power 8 plus 1. So that means x to the power 8 plus 1. Again, the sign is basically plus plus. That means that is also no variation. And here the number of negative real root, this is also 0. Now we come to the 0 root, f of 0. This is basically 0 plus 1. That means 1, 1, 0. So that means 0 is not a root. So obviously here the number of real roots this is equals to number of positive real root plus number of negative real root plus 0 as a root of multiplicity. This is 0 plus 0 plus 0. So that means 0. So here the number of real roots is 0. That means all the roots are complex. If you ask the number of complex root of the equation, it is exactly 8. Okay. So thank you so much. Have a good